Section 7.2, example 7, finding the area under the parametric curve. To find the area under the parametric curve of the cycloid defined by the equations below. All right, so this is actually a bit easier than it sounds because all we have is an equation or a formula. So the area under the curve as t goes from A to B, then we have y of t x prime of t, we're multiplying those two together, dt. Simple as that. So evaluating from A to B, this is whatever t is because we're integrating with respect to t. Y itself, we take the derivative of x and we just integrate that. So only time we're going to come up with problems is if we have like a kind of crazy integration, but something tells me it's not going to be that bad here. I don't know. Let's give it a try. So we have the area as t goes from A to B. We have our t values as t goes from 0 to 2 pi of y of t. Y of t is 1 minus cosine t times y prime of t. That's 1 minus the derivative is cosine t. Super simple, dt. And let's expand this. So from 0 to 2 pi. Give myself more room. So expanding that, we have 1 minus 2 cosine t plus cosine squared t dt. We can't just integrate this as is, so let's do the tough work here before we start integrating. 1 minus 2 cosine t plus cosine squared t is going to be 1 plus cosine of 2t over 2 dt. And let's pull out that 1/2. So when we pull it out over here, we end up pulling it out with the entire equation. So that's going to be 2 minus 4 cosine t plus 1 plus cosine 2t dt. Clean it up one more time before we integrate. We have a tough one, cosine. It's not really that tough, but we'll get through it. 4 cosine t and plus 3 dt. And here we get to integrate 1 over 2. The integral of cosine is going to be negative sine of 2t, but we can't just write negative sine of 2t. It's going to be negative 1 over 2 sine of 2t. So that way when we take the derivative, we should get right back to this. Plus, or actually minus 4 cosine t. I'm sorry, 4 sine t. No negatives. There we go. 4 sine t plus 3t, and we're evaluating that from 0 to 2 pi. Let's do this. 1 over 4 sine of 2t plus 2 sine t plus 3t. Yep, 3 over 2t. Evaluated from 0 to 2 pi. Let's evaluate. So we have 1 over 4 Sine of 2 pi is going to be 0 plus 2 times, I'm sorry, sine of 4 pi is going to be 0. Sine of 2 pi also going to be 0 plus 3 over 2 times 2 pi minus 1 over 4. Sine of 0 is 0 plus 2 times sine of 0 is 0 plus 3 over 2 times 0. And let's see what we're left with. So 0, 0, that simplifies, but we have zeros everywhere else. So our solution ends up being 3 pi. And that's it. All done. And yep, that's a wrap on the entire semester. Great job to everyone. And I can't wait to see what the future holds for everyone. If you have any questions, please feel free to ask. Otherwise, bye.